The next speaker will be Iles. I'm sorry if I pronounce wrongly your name.
Thank you very much. Yes, I've used a slide template from one of the previous LSSW workshops. So yeah, my name is Gail Iles. I'm a senior lecturer in physics at RMIT University. Next slide, please. So my proposal is to send instrumentation to the specific locations of localized magnetic anomalies on the surface of the moon. Is this a PDF or a PowerPoint?
It is a PDF. I could try to quickly pull up your PowerPoint if you want to keep talking.
It's okay. It's an animation of the magnetic field lines. It's not important. It's fine. We can leave it as an image. So the image is showing a simulation by Goddard, which is showing one of the magnetic anomalies with the turquoise and yellow arrows in the surface of the moon are indicating the direction of the magnetic dipoles. The gold lines are showing the lines of the magnetic fields. Red arrows indicate the electric field, and the blue circles or spheres are the protons which are interacting with this electromagnetic environment. Now, we're protected on Earth by our magnetosphere, and there's a complex interaction with the solar wind and the solar particles emitted by the sun. But we have this unique opportunity on the surface of the moon, which doesn't have its kind of a complete magnetic field, but instead has locations of very intense magnetic fields on a much smaller scale. And it would be fascinating to put some instrumentation at the site of these magnetic anomalies to investigate not just these small magnetospheres, but also the effects of space weathering on the surface of the moon, and in particular, behavior of the nanophase ion. Next slide, please. So the work would address multiple Artemis science objectives, including understanding planetary processes and perhaps the impact history of the Earth-Moon system, because many of these magnetic anomalies are occurring at the site of impact craters. And it would address conducting experimental science in the lunar environment. Next slide, please. So the four locations that I think are of particular interest are those with the highest magnetic field. So this map of the lunar surface has been obtained from the Lunar Reconnaissance Orbiter, so that's in orbit around the moon, and the strength of the magnetic fields is actually at 30 kilometers altitude. So the Rayner Gamma crater, Descartes, Ingenie, and Chrysium Antipode have this 15 nanotesla strength magnetic field, but as I said, that's at 30 kilometers, so it will be much stronger on the surface. Next slide, please.
This is 1 more minute.
Thank you. In particular, I think the Rayner Gamma crater would be the most interesting of those four magnetic anomalies, mainly because it's also at the site of the most amount of iron. And my suspicion is that the nanophase ion through space weathering is actually being levitated within these small magnetic fields. So if we could get some scientific equipment into that location, I think that would be that would produce the maximum scientific return. Next slide, please. So the criteria for the experiments would be that they must survive through the night. That would give a nice contrast between the positive and negative charging on the surface of the moon through the day-night cycle. There should be some radiation detectors, some particularly neutron spectrometers, perhaps some Mossbauer spectroscopy, and if it's possible to collect the ion, I think that would also be a good in situ resource utilization capability. And I'll end there to keep within time.
Thank you so much. It's a great presentation.